probably going to be confused too. All right. What do we call these things? What is this? What is this? Not a toy. Like, what is it replicating? What is it a replica of? A molecule. What is a molecule? These are both molecules. This one has 5 atoms. This one has 3 atoms. So what is a molecule? Go ahead.
They like make up substances and stuff?
Yep. Yeah, it's 2 or more atoms chemically combined. The best we can show in real life, like something concrete you can hold on to, is like this. It's called a ball and stick model. So that stick is a chemical bond. So when I take one atom and I combine it chemically with another atom, that's the simplest form of a molecule, 2 atoms, okay? And it can be actually 2 of the same atoms, right? Diatomic elements, that's a molecule, okay? So you might hear me say molecule today or down the road or all the time I say it. So what is a molecule? 2 or more atoms chemically combined. What is an atom? An atom is the simplest part of an element that retains all the properties of that element. That's what an atom is, the smallest part of an element. So if we had, you know, a piece of tin here, and I could somehow break it up into all of its individual atoms, okay, that would be the smallest piece of tin, and it would look just the same. If we could zoom in and look at it, it would look the same. It would act the same. That's what atoms are, okay? Smallest part of an element. So it's important to have a concept of what that means before we move on. So what is a compound? 2 or more elements chemically combined. Oops. 2 or more elements chemically combined. 2 or more elements chemically combined. That's what a compound is. Are compounds uniform in composition? Jen, what do you think? Are compounds uniform in composition? I'll give you some help. Salt is a compound. Yeah. Compounds, what's the bigger category? Elements and compounds are part of this bigger category. Go back, look at your little flow chart if you have to. What is it? Substances, pure substances. So compounds are pure substances. They also are uniform. I feel like it's redundant to keep writing it. Maybe we should. But any substance is uniform. What are substances? Elements and compounds. Okay? So compound is part of the substance. So compounds are uniform. Compounds can be broken down. And Ryan, it's your lucky day. We're going to talk about something you want to talk about all the time.
What's that?
So we can break compounds down. How can we break compounds down? You bring it up almost every day. Electrolysis.
Yeah, electrolysis.
You can break compounds down chemically. And electrolysis is a good example of that. Okay, it's good though, because I think the fact we talk about it a lot, everyone will remember that. What is electrolysis? Breaking a compound down. Let's use an example here. NaCl liquid. So if we have molten salt, liquid salt, which is ridiculously hot, 801 degrees Celsius, because that's what it takes to melt salt. You with me, Zach?
Yeah.
Sure.
Have you ever done electrolysis?
Yes.
Was it cool?
It's okay.
Can you try it?
Maybe at the end of the year or something. But you
Maybe
can split water.
Yeah, I know. That's all I can find.
That's the easiest thing to do. You can't just take electricity and run it through water. It doesn't necessarily work too well, so you got to tweak it a little bit. Anyways, back to this. If you take molten salt and you run electricity through it, ELEC, you run electricity through molten salt, you can separate the Na from the Cl. You can't physically separate salt. I can't take a super sharp, almost whistled there, super sharp knife, slice the air, and get all types of elements popping out of the air because I just sliced the compounds that are in the air, okay? You don't get carbon falling from the sky and oxygen when you split CO2. You can't do that with a knife, okay?
What if there was a thing that's an electrolysis knife?
In your world, yes, that would work.
Could it be possible if like I invented it? I could slice them down the middle. Bang.
As far as my brain understands things in this world, no, that's impossible.
That's dope.
All right, so liquid salt would break into sodium and chlorine gas. Sodium is solid and chlorine is a gas. That is an example of a chemical reaction, a way to show the formulas for what this means. You can take a compound like salt and break it using electricity, chemically, into its original elements. That's why you can break compounds down but not elements, because they are made of elements, right? This is called decomposition. Decomposition. When something is broken down chemically, we say decomposition. That's what that reaction type is called. Okay, take a compound, break it into its elements. Okay, why Cl have a 2?
Because in NaCl too, so there's 2 chlorine.
It's NaCl. It's just NaCl.
Well, because it felt like duplicating itself.
Who remembers?
Because doesn't it need to cancel out the...
Nope, something else. Good try. 7 of those elements get 2s. What are they called?
Oh.
What are they called? What's the acronym? Starts with an H.
Halogens? No, that's wrong.
The 7 diatomic elements. Honkelbrief, right? Uncle Honkelbrief. Honkelbrief. H-O-N-C-L, B-R, and I, and F. They exist in pairs. Like this. The 7 diatomic elements exist like this, okay, in molecules. That's why that 2 is there. Whenever chlorine is by itself, not in a compound, it always has a 2 because it's diatomic. Now, this equation's all messed up. We need to balance it. Got to put a 2 here and a 2 there. That might not make sense to anybody. That's okay. We're going to spend a lot of time on that down the road. The reason I put these 2's here is because I need 2 NAs, 2 NAs, 2 CLs, 2 CLs on both sides of this arrow to make it balanced. Okay, that's why we do that. Don't worry if you're confused. I just can't leave it incorrect. I have to show you the right way to do things. So that's an example of breaking a compound down. Okay, so that's a compound and just part of what we're going to talk about. Hold on. I got to consult the notes so I don't forget something here. Oh, right. Compounds always form in the same proportions. What in the world does that mean? The same proportions. What does that mean? You guys ever make oatmeal? Like not from a box? Like you just buy straight up oatmeal and then you cook it on the stove? Okay. How do you know how much oatmeal to add and how much water or milk?
You eyeball it.
No.
No, it says on the...
It says on the bag or box or whatever. It says on the container that the oatmeal comes in. Well, so I like to make oatmeal, and I always like to make 1.5 of what it says on the bag. So it usually says 3 cups of water, but I use milk. So 3 cups of milk and 1 cup of oatmeal. So I like to make it 1.5 times that. So I use 1.5 cups of oatmeal and 4.5 cups of milk. Every single time I use 4.5 cups of milk, 1.5 cups of oatmeal, and I do that every time I make it. I get the exact same amount of oatmeal every time. Why does that make sense that I get the exact same amount every time? Because I use the same amount every time. That's what this means. So when compounds form, they use the exact same amount of elements every time they form. Every time they form. Give me an example of the most common compound. H2O. Guess what? Every time water is formed on this planet, it's formed in that proportion. 2 H's for 1 O. It's a 2-to-1 ratio. 2 H's to 1 O. Water on other country or continents or other rooms or at home, water anywhere else in the world is the same, H2O. It doesn't change. That's what that means. compounds always form the same proportion. Salt is always NaCl. That never ever changes. It's never Na2Cl4. It's never H3O, it's always H2O. That's what that means. That's actually really important to know. Whether you fully get it, it's important to remember that, okay, that the water is H2O and it can never change. If you start messing with these subscripts, guess what? It's not the same compound. It's not water, it's not salt, it's something else. I'm going to show you that in a second. Yes?
Unlike other planets, are they all the same elements? Or are they
Yes.
different elements?
Our universe has all the same elements. Our galaxy. As far as we know. But the interesting thing about that is a lot of astronomers and scientists think that a lot of the elements that are on our planet didn't originate on this planet.
So, like,
Comets and asteroids, when they crash into Earth, brought the elements. No,
So we can
they were
discriminate.
on these other, celestial beings.
Yeah.
I'll call it. So comets, asteroids, whatever, they crash into
no, I
Earth.
was just wondering, yeah,
And
because,
that's
like,
where a
there's
lot of
no
elements
feed
came
in
from.
water on Mars. I was wondering if they'd be like the same.
It's the same, H2O, right? It's the same. There's methane lakes on some moons and planets. There's ammonia out there, and that's all the same. NH3 is ammonia here. Out there, it's NH3. CH4 is methane here. CH4 on those planets. So it's the same. It's the same. But this is going to be confusing. Compounds can also form. Oops, not always. Can also form in multiple proportions. That's kind of contradictory to what I just wrote. What does that mean, contradictory?
Opposite.
Yeah, the opposite, right? Let me explain. Nitrous oxide and nitrogen dioxide. That was a good question, Ryan. I'll give you credit for that. That was a good question.
What question?
Never mind.
Okay.
One about space, the universe,
Oh.
the elements. All right, nitrous oxide. You guys heard of that? Some people? What to do? Does a couple different things, but what does everyone, especially guys or boys always think of this first. No offense, girls, but guys seem to be more excited about this.
What?
What nitrous oxide does. Kristen knows. Cars, yeah, it makes cars what? What? Go fast, really quick, okay? Yes. Kristen, you corrected me. N2O is nitrous oxide. N2O is nitrous oxide. Now, use your brain. What's the formula for nitrogen dioxide? You know what carbon dioxide is. You know what's carbon dioxide? What's the formula? CO2, so this is, like Zach said, NO2. Here's what I'm showing you. The first thing I wrote, first bullet, that's correct. That is 100% true. But this is also 100% true. Sometimes the same elements in different compounds have different proportions. What does that mean? When N and O combine to make a compound, it's not always forming the same compound. Sometimes it forms a different one. And when it forms a different one, the proportions change. It's opposite. This is 2 to 1. This is 1 to 2. So compounds always form the same proportion, but only for that specific compound. If it makes a new compound, it'll have a different proportion, but that proportion is always formed as well. In other words, nitrous oxide is always N2O. Nitrogen dioxide, always NO2. They're different, but they're always the same with each other. In other words, any NO2 molecule formed anywhere in the world is always this. Any N2O molecule is always that. So both of these laws are true about compounds. So I just wanted to explain that it's not always the same ratio. It can have multiple proportions. Okay, and the last thing, give me a couple more minutes here. Last thing, if we get cut off, don't forget, book work due tomorrow. Here we go. I know it's ringing, oh, she's got it. Here we go, last thing. Compounds have properties that are different, underline different, than the properties of the elements that form it. Or make it up. That's a better way to say it. That make it up. Compounds have properties that are different than the properties of the elements that make it up, it being the compound. So, I'm trying to get this out quick. Sugar. Does anyone know what 3 elements make sugar? Anyone know the formula for sugar? How would you know the formula if you don't know that? Alright, what's glucose? Oh boy.
Wait, hold on a second.
It's a starch. No.
Oh wow.
Oh, glucose is a sugar.
C6
H12.
H12O6. That's glucose. Sugar is 2 glucose molecules combined by dehydration synthesis. We'll talk about it tomorrow. Don't forget the bookwork.
Brianna has to go to the office. Okay.
Thank you.